Okay, so first we need to make sure we are on the right page. We are doing the mid-chapter checkpoint. We are on page 233. Okay, mid-chapter checkpoint, page 233. Okay, number one, a number that is the product of a number and a counting number is called a, okay, so the product is going to always be the answer of a multiplication problem. So it's the product of a number and a counting number. Okay? But what kind of number would that be? Okay, it would be a multiple. Okay? Number two, numbers that are easy to compute mentally are called, so we have to think about this. These are going to be numbers that we can figure in our head. Okay? And this is compatible numbers. So we used multiple, okay? These are going to be compatible numbers. Compatible, think of compatible as easily going together. Things are compatible means they fit just right. Well, this is something that are easy to compute in your head. Compatible numbers. Okay? Number three, when a number cannot be divided evenly, the amount left over is called the blank. The key in this sentence is left over. Okay? The number that is left over is called the remainder. So if you have a story problem, and if it's ever asking what is left over, or if it wants to know how much is left over, you will refer to the remainder to be able to answer that question, okay? All right, number four. It says divide. Draw a quick picture to help. I left this part, the picture part, optional to the kids. If they could divide it without drawing a picture, that's perfectly fine. If a picture helps you, then go ahead and do a picture, okay? So let's look at this. 26 divided by 3, okay? So one way to think about this is our dividend, this is our divisor. 3 is our divisor, okay? We want to know how many times our divisor can go in our dividend without going over. So we want to know the most times 3 can go in 26 without going over 26. If you have your multiplication chart, a quick way to also look at this is 3 is what we want to know. So we look at our 3. This is our divisor. We want to know the most it can go into 26 without going over. Okay, we're at 24. The next number is 27. That is more than 26. So we cannot use this number. So let's look. What is before the 27? 24. That is the biggest amount we can use without going over 26. So the amount of times is 8. Okay, so we would write the 8 down. Okay, but did we use all 26? No, only 24. Okay, so if we take the 24 from the 26, we are left with 2. That is our remainder. Okay, 3 can go into 26 times. 3 can go into 26 8 times. Okay, now, however, 3 times 8 is 24. Okay, we did not get all the way up to 26. We had 2 left. That is our help. Okay? Four going into 19. We want to know how many times 4 can go into 19 without going over. So you start thinking of multiples of 4. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. Oops, 20 is too big. So we have to go the one spot under that. And once again, if we want to use our chart, 4 is our divisor. We want to know how many times it can go into 19. So 4, and let's keep looking. Oops, we said 20 is too big. We got to go to this notch here. So 4 can go into 19 4 times without going over. So we would put 4. And what is 4 times 4? 4 times 4 is 16. So this is what we take from our dividend to find our remainder. So 19 minus 16, and if you want to do this part in your head, that's perfectly fine. 19 minus 16 is 3, so our remainder is 3. Okay? Number 6 says, use basic facts. Let's see, I want to make sure you guys can see this. Use basic facts and place value to find the quotient. Okay? Basic facts, or sometimes I call them special facts. All right? So we want to look at this number, or dividend, and see if there's anything special about this. Okay? That makes us think about our divisor. Is there a special fact or basic fact that our divisor can go into? Usually we look at the first number or two, which is 81. Let's think to ourselves, can 9 go into 81? It can, and that's what makes it a basic fact. We know that 9 times 9 is 81. If you need help, you can always refer to your chart. 9, maybe keep going over and over, 9 times 9 is 81. Okay? So 9 can go into 81 9 times. Okay? We use the 8 and we use the 1 to figure that, but we have a 0 left over. When we have a 0 left over, we just put it at the end. So let's look at number 7. Our basic fact or special fact on this would be 21. In our heads, we know that 7 can go into 21 3 times. So we write down the 3. We have a 0 left over, so that will go at the end of it. That is a quick way to compute. 210 divided by 7 is 30. Okay. Let's look at number 8. Okay, let's look at the number 3,000 and think, can we pick out a basic fact or a special fact that 6 can go into? Okay, you can use your chart if you would like. Or if you have your math facts really good in your head, I know right away, I know that 6 can go into 30 and it's jumping right out at me. I can see a 30 right there. I know that 6 can go into 30 5 times. Okay, now when doing this, I use the 3 and the first 0 to come up with that. I have this 0 and this 0 left. I haven't used them yet. I've already used this 0 right here. So I don't put 3 back here, I only put 2. Because I used the first 0 and the 30 when I put 6 into it. So that one was used. The 3 was used, the first 0 was used. I have 2 zeros left over, they go back here. As a really quick way to compute 3,000 divided by 6. Number 9. It says use compatible numbers to estimate the quotient. Okay. Compatible, meaning something easy in our heads. Okay. The other word we need to look at is this. Estimate is a key word. So, like above, we try to find special facts. We're still going to think of special facts or basic facts in our head, but we're going to estimate. Estimate. So, is there a number really, really close to 63 that we know that 9 can go into? Whether it's below or above, whatever is closest, whatever is closest. So let's look at 9. Okay, the number is 63. I pulled out the first 2 digits, okay? So let's find a number with the 9 row, that's the closest to 63. So let's look at 9s. Pan out just a minute. Okay, so let's look at my 9 row. I'm going to look at 9 and I'm going to go all the way across. What's closest to 63? I found something right on 63, and it is a 7. A 7. Okay, we didn't have to go below or above because I found something right on 63. The 7. So I can write a 7 down. Okay, so because I'm using the 63 and I'm estimating, I'm just going to turn the 5 into a 0. Okay? So I turn this into 630 divided by 9. 9 goes into 63 7 times, and I have a 0 left over. So a quick estimate that's compatible is 70. Okay, let's look at the next one. 412 divided by 5. Okay? What would be a really quick estimate that is also compatible? So let's look. Let's pull out the 41. Okay? What is really close to 41 that 5 can go into? Well, let me look at my 5 row. My row of 5. So here's my 5. This is my divisor. Let's see what's really close to 41 that 5 can go into. I have a 40 and I have a 45. I want the closest one to 41. 40 is closer than 45. So I'm going to use 40. Okay? So I will turn the 41 into a 40. And the 2, I'm just going to make a 0 because it's an estimation. Now, if I pull a basic fact or a special fact, I can look at this and know that 40 is jumping out at me. How many times can 5 go into 40? It can go in 8 times. I used the first 0 in taking 5 into 40, so I have 1 0 left over. So this quick estimate is 80. Okay, let's look at number 11. Once again, let's find an estimate. Okay, we're going to look at the 49 and think, what is really close to 49 that 8 can go into? So you can either do it in your head or you can use your chart again. My divisor is 8. We'll look over what is really close to 49. Okay, I have a 48 on one side and a 56 on the other. Which one is closest? The 48 is the closest to 49. Okay, so I'm going to use the 48. And it's already a 0 for us, so I will just make that a 0 and divide that by 8. Okay, if I pull out my basic fact or my special fact, 48, I say, how many times can 8 go into 48? You're right, it's 6. And I can also get that by looking at my chart. 8 goes into 48 6 times. Okay. Now, I use the 4 and the 8. Have I used the 0 yet? No. So I need to put that behind my 6. a quick estimate to this is 60. Okay. It says use grid paper or base 10 blocks to model the quotient. Okay. Well, if you use base 10 blocks are the ones that look like this. I use one line for a 10, and I use a dot for a 1. You see that? So this makes 11. If I want to say 23, I would go 10, 20, 1, 2, 3. Those are called base 10 blocks. Okay? So, if I want to do 63 divided by 3, my divisor is 3. So right away, I'm going to have 3 circles. 1, 2, 3. Base 10 blocks, I'm going to have 63. 1, probably 10, 20, 30, 40, 50, 60. And then my ones, I have 1, 2, 3. Okay? Now, if I'm going to distribute these equally, I always know I have 3 circles based on what my divisor is. My divisor was 3, so I have 3 circles. I'm going to start putting these, distributing them to my circles. So I'll take this guy and put him here. I'm going to cross him out because I'm done with him. I'll take this guy and put him here and then cross him out. This guy and put him here. Whoops, he should have went there. Cross him out. This guy, I accidentally already put him there. So I'm not going to make a new one, but I'm going to cross him out. This guy needs to go here, cross him out. This guy needs to go here, cross him out. I have now distributed all of my 10s equally. I am left with 3 ones. Luckily enough, I have 3 circles for my divisor. So I can take my ones and distribute them equally. I have now taken care of all my base 10 blocks. My answer is going to be whatever is in one circle. I know that these are 10s and these are 1s. So I have 10, 20, 21. My answer is 21. Okay? If you are not wanting to use base 10 blocks, you don't have to. So let's look at 13. 85 divided by 5. Okay? We can think of how many times can 5 go into 85 without going over? Okay? Now, if we were to use base 10 blocks, my divisor is 5, so I need 5 circles. 1, 2, 3, 4, 5. Okay? Base 10 blocks, I have 85. 10, 20, 30, 40, 50, 60, 70, 80. Then I have 5 ones. 1, 2, 3, 4, 5. Okay, now as I distribute them equally to my circles, which stands for my divisor, I will put this guy here, cross them out. Put this guy here, cross them out. 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 Put this guy here. I'm going to start over again. Oh, wait, could I have started over again? Ooh, I shouldn't have done that. I shouldn't have put that guy there. Okay, because I only have 3 10s left and I have 5 circles. So now, when we did the distribution property, we turned all of these into 1s. So I now have 35 1s, and I'll write that number down. So now I need to distribute 35 1s to my circles. I know that 35 divided by 5 is 7. So I know I can put 7 1s in each of my circles. And this one I know is kind of hard to see. 1, 2, 3, 4, 5, 6, 7. Okay. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6, 7. So how many are in each circle? I know I didn't do a very good job of being artistic. So there's 7 ones and 1 10, which is 17. Okay. We would do the same thing for 14. If you want to draw a picture, you can, or you don't have to. All right, I see a couple special facts here, so I'm going to do it a little bit differently. I know if I break it apart, this just happens to jump out at me. The 16 jumps out at me, and the 8 jumps out at me. I know that 8 can go into 16, and I also know that 8 can go into 8. In my head, I know that 8 can go into 16 2 times. I also know that 8 can go into 8 1 time. But that only works if there's special facts or basic facts that jump out at you. Let's see if can you guys see that? Okay. Okay. Page 234. Anna has 296 coins in her coin collection. She put the same number of coins in each 7 jars. About how many coins are in each jar? Okay, so what kind of a problem is this going to be? Okay, this is going to be a division problem, and it's going to be 296 divided by 7. Okay, the key here is it says about how many. Whenever you see that, it's going to be an estimate. Okay, so we need to look here and see, is there an estimate that we can use with 29 that 7 can go into? That's really, really close. Okay, we can look at our chart if we want. We would look at 7 and try to find what's the closest to 29. I have a 28 and I have a 30. 28 is the closest to 29, so I would go with that one. So the 29 would then turn into 28, and because we're estimating, we would just make this a 0. Now, when you look at this, a special fact jumps out at you. I see the 28. I know that 7 can go into 28, and I know that 7 can go into 28 4 times. I've used my 2 and my 8, and I have a 0 left over. So I would fill that in. My answer is 40. I also need to label my problem with coins. Okay, so right now, you see if you can figure out 16, we crossed out 17, 18, and 19 on your own. When you are finished, you can take a picture and post all of your work to Seesaw.